So we've got to show that if x cubed minus x is bigger than 0, then x is bigger than minus 1. I reckon it's a good idea to draw a picture of what's going on just to explain this question. But we're going to use the contrapositive because that's the exercise that we're doing. So in terms of what's going on, we've got a cubic, y equals x cubed minus x. So that's like x into x squared minus 1. So that's x minus 1 and x plus 1. So your cubic, there's your 1, there's your minus 1, there's your 0. And your cubic looks something like that. All right, and it goes. All right, now they're saying suppose that this cubic, this yellow, is bigger than 0. So suppose you're in either this part or this part here, right? That's where it's bigger than 0. Then x is bigger than minus 1 in that case. Well, yes, it is. It's bigger than minus 1. Now, note that it's not saying that for all values of x bigger than minus 1, that picture, that yellow picture, is bigger than 0, right? Because there are some values where it's less than 0. But it is saying if you're in the purple bit that I've drawn, then x values must be bigger than minus 1. All right. Now, if we look at the contrapositive, then if you look at the yellow bit that's left, that's going to be talking about something. So let's write down what the contrapositive is. The contrapositive is if x is less than or equal to minus 1, then x cubed minus x is less than or equal to 0. Now that's making sense from the picture, isn't it? Because I'll just grab an orange one. Okay, if you head out there, right, all your x values, where I'm colouring orange here, that's where x is less than minus 1. And when you look at the picture, it's underneath the x-axis, so it is indeed less than or equal to 0 out there. So I can see that the truth of the statement, like Hetty is correct. If I couldn't find another way to do it, I would argue this one with a graph. But I'm going to use the contrapositive here and do it that way. So using the contrapositive, let's just get a different colour pen there. So x is less than or equal to minus 1 is the given situation, all right? So therefore, x squared will be bigger than or equal to 1. Now, that's kind of not going to be helpful in the long run. So I'm going to say minus x squared is going to be less than or equal to x, because we've got something whose size is bigger than 1. It's not a decimal. So when you square it, it gets bigger. All right. So in terms of its size, and if you cube it, then the size of it gets bigger still. Now, if you're looking at a even power, then what's happening is you end up with a positive answer. So I had to put a minus sign in front of it. So I might just erase this and try and express myself a bit better. I might say since the size of x is bigger than or equal to 1, then x squared will be bigger than or equal to x, and the size of x squared will be bigger than or equal to the size of x, and the size of x cubed will be bigger than or equal to the size of x, right? Now, since x is negative, we would say that negative of x squared, that turns out to be smaller than x. That would be the interpretation that you would have of what you've written there. And x cubed, of course, would be smaller than negative of x squared, which would be smaller than x. So if x cubed is less than or equal to minus x squared, which is less than or equal to x, then x cubed is less than or equal to x. So x cubed minus x is less than or equal to 0. Now that's what we wanted in the blue there at the top of the screen. So we've proved it. So since the contrapositive is true, the original statement is also true. I.e., if now they're saying here the original statement is that if the picture is bigger than 0, then you must be bigger than minus 1. If x cubed minus x is bigger than 0, then x has got to be bigger than minus 1.